In this video, we're going to look at an elimination reaction, specifically dehydrohalogenation. And we're going to look at this through the dehydrohalogenation of 2-bromopropane. So to start, we're going to do a quick overview of what dehydrohalogenation is. I'm going to start by drawing chloroethane. So I'm going to have a chlorine on one carbon and all hydrogens on the other, and single bond between the two carbons. In dehydrohalogenation, we're going to react our alkyl halide with a hydroxide, so a strong base. We're going to only use hydroxide in this course, but as you go on in organic chemistry, you'll learn that there are other types of strong bases that can also do this job. So when these two react, we're going to form a double bond between our carbons, resulting in ethene in this case. And we're going to have some byproducts. So one of our byproducts is going to be water, and the other is going to be our halogen, so Cl-. The reason that this is called dehydrohalogenation is that you are removing a hydrogen, so that's the dehydro, and a halogen, that's the dehalogen, from the alkyl halide to form the double bond. We're going to look at the example of 2-bromopropane now. So I'm going to draw this as a structural diagram just so we can see the carbons and the hydrogens a little bit more easily. So our bromine is going to be on carbon 2, and the rest of our carbons will have 3, 1, and 3 hydrogens. For dehydrohalogenation, we're going to be adding a strong base, so hydroxide. And what's going to happen in this reaction is we're going to remove our bromine and an adjacent hydrogen. So we're going to look at the carbon next to that bromine. In this case, it doesn't matter which carbon we take from, we'll get the same product. So we're going to look at that carbon next to the bromine, and we're going to be taking one of the hydrogens from that carbon. Again, it doesn't matter which one we choose, so I'm going to choose just this top one. So we're going to take a hydrogen from one carbon and a bromine from an adjacent carbon. That's going to allow us to form a double bond between those two carbons. Our third carbon is going to remain exactly the same. So we still have one hydrogen left on our carbon with the bromine, and we'll have 2 hydrogens left on our terminal carbon. We now have a double bond. And our byproducts, our inorganic byproducts, are going to be water and Br-. And for this water, this is the OH plus that hydrogen from the alkyl halide. So this is the dehydrohalogenation of 2-bromopropane, and in doing so we create propene. And we will always create a double bond and sometimes a triple bond with this reaction.